Alright, this 7.6, solving exponential equations. There's two types. There's one where you can match up the bases and solve it, and there's one where you can't. So first, exponential equations means, so that you can identify when you need this, is when the variable is in the exponent. So when the variable that you're trying to solve for, like x, when variable is in the exponent, that's when we can't just take the x root of something, so we have to be a little more clever. So we'll do we'll start with this example. Let's say you have 9 to the 2x power equals 27 to the x minus 1 power. So all these they're solved for x right now. So what you want to recognize is first the variables in the exponent. This is an exponential equation, but you can get these in the same base. So between 9 and 27, what's the common base that we could rewrite both 9 and 27 in? So a number raised to a power would equal these. 3, good. Good. So that's the first thing you have to recognize. 3 to the what power is 9? 3 squared, and 3 to the what power is 27? 3 cubed. Yeah. So we rewrite the 9 as 3 squared. 3 squared. It's still raised to the 2x power. And we rewrite 27 as 3 cubed, and it's still raised to the x minus 1 power. And that right there would be the hardest step. So now that they're in the same base, let's just simplify this a little further. This is 3 to the 4x power equals, and this is 3 to the, we can actually distribute the 3 to both of these. This is 3 to the 3x minus 3 power. You just distribute the 3 to both. And when the bases match like this, you can equate, what I'm going to do is equate the exponents. Equate the exponents to each other because they have the same base. So you just write 4x equals 3x minus 3. So we don't need those bases anymore because they're the same, and now we have a basic linear equation to solve for x. So you would just subtract 3x from each side. Minus 3x gives you x equals -3, and that is, I've solved for x. Let's do another example. Let's try 3 to the x power. One last example. 3 to the x power equals 1/9 raised to the x plus 3 power. Okay, so this is the last example of this type. So again, the 3 and the 1/9, even though it doesn't look like it right away, can be written in the same base. So of 3. So this stays the same, 3 to the x. 1/9, what can you rewrite 9 as? Yeah. So at first I'll just write 3 squared so you can see this step by step. 9 is 3 squared. That's all. I'm just doing it one step at a time. And then hopefully you can connect this to the previous unit on exponents. Yeah. To make it just 3, you make the exponent negative. You take the reciprocal, and this 3 to the 2 becomes 3 to the -2. So now these are in the same base of 3. We don't need those anymore. So we just equate the exponents again. Same strategy. So x equals -2 times x plus 3. -2 times x plus 3. And then we distribute the -2. I think you're ahead of me. -2x minus 6. And then add 2x to each side. Divide by 3. X equals -2. So that's the first part. And then moving on to part 2,